Today we're just going to take a quick look at why atoms form bonds, right? Atoms are neutral. Atoms are neutral because they have the same number of protons and electrons. Protons have a positive charge, electrons have a negative charge. And atoms like to be neutral because protons attract electrons. But that's not the only thing that's going on in an atom. Okay, if we grab a periodic table and take a look at say an A group element. Okay, the A group elements here are highlighted in red. The B group elements are these transition elements in the middle. They're in blue. But these red elements, okay, we can predict a whole bunch of things about them, right? Remember, if we see it in the first column, then we know it's got one valence electron. We see it in the second column, it's got two valence electrons. 3A, 4A, 5A, 6A, 7A, 8A, right? We know how many valence electrons they have. Well, all these atoms are neutral, but they all want to not only be neutral, they want to be stable, okay? And so, like helium is a stable atom because it's got a full electron shell. It's got two electrons in its only energy level. The first energy level only holds two. It's stable. So lithium starts over. It fills up the second shell as we move from left to right. And so neon is stable. It's got a full electron shell. It's got 8 electrons in that shell. Okay, so sodium starts over in the next shell. And as these continue to fill, okay, once they get to 8, they start over. Okay, and so 8 is a stable number for almost everything except hydrogen and helium. If they can get to 8 valence electrons, atoms are stable. Okay, well, it's tricky to get to 8. Okay, if we take a sodium atom, and I guess I want that periodic table back real quick. If we take a sodium atom, sodium is right here. Sodium has 11 protons, so it's got 11 electrons. And it's got a whole mess of stuff going on. Okay, so I'm going to draw my nucleus and I'm going to put in my 11 protons, and there's some neutrons in there. Don't know how many, didn't have an isotope. Okay, alright, so 2 electrons here, 8 electrons here. Second energy level holds 8. Okay, 4, 5, 6, 7, 8. Okay, that's 10 electrons. It needs one more in order to be neutral. Okay, one more electron hangs out here. Okay, well, this electron is all by itself. There's a whole bunch of empty spots out in this energy level, and that makes this a very reactive metal. This electron is not bound very tight. Okay, it's easy for it to get away. And if it does get away, then this element, sodium, will drop down to this energy level. Okay, where all it's got left on it is the 2 in the inner side and the 8 on the outside. That's a stable configuration. That looks like a noble gas. It's got 8 valence electrons. Okay, this is the goal of atoms, to get to 8 valence electrons. But you'll notice to do that, this sodium atom had to give away an electron. Okay, now it's only got 10 electrons, 11 protons. It's got a positive charge. Okay, well, atoms like to be neutral, but they also like to be stable. So when atoms give away electrons or gain electrons, you end up with oppositely charged atoms called ions, and the ions stick together to make bonds, to make compounds. Okay, so that's what's going on. So I guess the very first thing we want to do to figure out what's going to happen with an atom is we got to figure out how they form bonds, if they're going to give away electrons or if they're going to take electrons. Okay, this is pretty simple. Metals always give away electrons. Okay, and if you give away electrons, you're going to end up with a positive charge. They give away electrons and they end positive. Okay, how many positive they end up depends on how many electrons they give away. Nonmetals, they're closer to having 8 valence electrons. They take electrons, and if you take negative charges, then you're going to end up negative. Okay, so these end up negative. And the easiest way to figure out what's going on is to use an electron dot diagram. Okay, and electron dot diagrams are very, very simple. An electron dot diagram just shows valence electrons for the element. Okay, so the valence electrons are important because the valence electrons are the things that show how reactive it's going to be, what it's going to do, how it's going to form bonds. Okay, so this just shows valence electrons for an element. And in order to draw these, I basically want you to follow 2 rules. Rule number 1, no side has 2 electrons. Okay, E minus is the sign for electrons until each gets 1. Okay, and rule number 2, only 2 electrons per side. Okay, and so when I say side, I want you to think of the element actually in its box on the periodic table. So sodium is Na. Okay, but if you look on the periodic table, didn't draw a very straight line. Okay, sodium is Na, but if you look on the periodic table, you'll see that sodium is actually in a little box, right? And so when you're drawing electron dot diagrams, I want you to think of the element in its little box. Sodium is in the first column, so it can have 1 valence electron, and you can put it on whichever side you like, but you can only put one of them on there. If we were to look at oxygen, okay, oxygen is in group 6. It's got 6 valence electrons, so we can go 1, 2, 3, 4, 5, 6 valence electrons. Okay, and if we were to look all the way at the end, let's say argon. Argon has 8 valence electrons, and so when we draw it, we would go 1, 2, 3, 4, 5, 6, 7, 8. And so when I say sides, I'm talking top, bottom, left, right. Now when you actually draw electron dot diagrams, you don't put the elements in the boxes, right? You just write the symbol, and then you add the little dots for each valence electron that it has. Okay, how does that help you? Well, if you can draw the electron dot diagram, then you can predict what it's going to do and what its charge is going to be. Okay, remember, all atoms, with the exception of helium and hydrogen and lithium, I suppose, but all atoms want 8, and now I'm going to say this, or 0 valence electrons. Okay, now 0 really doesn't mean 0. 0 means they're going to drop down into the lower energy level and have a full electron shell again. But for practical purposes, we consider it as 0. Okay, so all atoms want 8 or 0 valence electrons. So when we look at a sodium atom, we look at that with its 1 valence electron. We can say, oh, it'll give that away. When it does that, sodium ends up with a 1 plus charge. It's got 1 extra proton compared to its electrons, because it started as neutral here. They all start neutral, but now it gave away a negative. It ends up positive. Oxygen with 6 valence electrons, okay, it's not going to give anything away. It's closer to having 8. It'll take an electron here. It'll take an electron here. So we end up with 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. But now it's a 2 minus charge. Okay, it took 2 negatives, so now it's a 2 minus ion. Okay, now just like before, atoms were neutral because the protons attracted electrons until the charge is balanced. Well, these ions aren't neutral anymore. They still want to be. Okay, and that's when ionic bond comes in. They're not going to necessarily give or take their electrons back. Okay, but what's going to happen is they'll stick with an oppositely charged ion. Okay, so a positive ion like a sodium ion, this is called a cation, and a negatively charged ion like oxygen is called an anion. Okay, and the amount of charge actually matters, right? This sodium gives away 1 electron, this oxygen takes in 2, but that's not going to balance each other out. So when we look at ionic bonds, we're going to have to take a little bit closer look at how we get these charges to get together and actually balance out. And by balance, I mean add up to 0. Okay, but for now, what I want you to understand is the valence electrons determine what the charge is going to be. And there's another way to look at this. Okay, if you don't like keeping track of what's going on with plus and minus, you can think of it this way. Oxygen, okay, or anything like oxygen, has 2 empty spots. So it's 2 electrons short of being stable. So that's sort of what this 2 minus means. It's 2 electrons short of being stable. Okay, this sodium atom has 1 extra electron. It's got 1 too many to be stable, so it's got a 1 plus. Okay, if that helps you, you can go with it that way. Okay, but make sure you know how to draw an electron dot diagram for an element. Okay, now there's only one other trick that comes into this, right? If it's an A group element, to get the number of valence electrons, all you have to do is look at its column number. Okay, so here's my periodic table again. Everything in column 1, these guys, 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, 8 valence electrons. That's pretty easy. Okay, what about these B group elements? Okay, well those ones are also pretty easy, because since the rule for that is complex and they can form multiple ions, I tell you what those are going to be. I'll tell you like iron 3. Okay, and to write 3, we put it in Roman numerals. All that Roman numeral means is 3 valence electrons. Okay, and so when you draw its electron dot diagram, you just iron is Fe, 1, 2, 3, and then the rules are exactly the same. It gives away 3 electrons to become positive, so it'll be a positive 3 ion. Okay, and metals will always give away their electrons.